Hello! I am going to tell you about a mistake I made on quiz Connectivity 10B. So this is a synthesis problem in this quiz, and it starts with this cycloalkene and makes this cyclic molecule with two C double bond O's. Those are two ketone groups. And there's three different sets of series of reagents, and it says which of the following are the correct reagents for the synthesis shown here. It says mark each one that's correct. Well, the first one is MCPBA, followed by, the second step, water with H3O+, followed by sodium dichromate with acid and water. And so if we start out with the alkene and add the MCPBA, we get an epoxide. And this is in acid conditions because we've got the H3O+. And so that means it's Markov-Nikov. But since both of these carbons have equal substitution, that doesn't really matter. We know that this has anti-addition, which means the nucleophile comes from the back side and opens up the epoxide to give us a diol, and because it's anti, it's a trans diol. Oops, didn't have enough room for trans there, so I've drawn the trans diol. The third step is the strong oxidizing agent, chromic acid, and I wrote an oxygen in brackets because that's easier to write than the whole sodium dichromate, acid and water. We know that that oxidizes the alcohols, the secondary alcohols, to ketones. So yes, we do get the target with the first set of reagents. The second set of reagents also starts out with MCPBA, but it's followed by osmium tetroxide, which does not react with epoxides. So actually, technically, this one does not work. And whenever you use the osmium tetroxide, you need to follow with an oxidizing agent to complete that. So it's like these two are one synthetic transformation. And then we have a strong oxidizing agent. So if this didn't have the MCPBA, then it actually would work. Let's see, I need a double bond here. Because the osmium tetroxide reacts with an alkene, not the epoxide, to give a cis diol. So we've got the 1,2 diol there. With the osmium tetroxide followed by that oxidizing agent H2O2. And then the KMNO4 is again a strong oxidizing agent that's able to oxidize those secondary alcohols to ketones. So if the second one didn't have the MCPBA, then it would work. But this osmium tetroxide won't work on an epoxide. So we need, if MCPBA can't be there if it's going to work. With the MCPBA there, we shouldn't check that one as working. The third one also works. It said literally metachloroperoxybenzoic acid, which is MCPBA, so you might see either on a test or quiz, followed by the good old water with H3O+, and then followed by PCC. And this will work because the alkene plus the MCPBA, so step one, gives us the epoxide, and we learned earlier that when we open it with acid conditions, and the water is the nucleophile, we get a trans diol, and these are both ketones, and ketones do react with PCC to give us, did I say ketones? These are secondary alcohols, and alcohols react with PCC to give ketones. I was thinking ahead, thinking of the product Okay, so PCC will react with primary alcohols to give an aldehyde, and PCC reacts with secondary alcohols to give ketones. So the first one here, yes, and the last one, yes. The middle one, no, as written. And I apologize for making this mistake in my key because it gave you a lot of confusion at a time when you're just learning these. And so my apologies. And if you have any questions, let me know. Send me an email. Stop by my office. I am glad to help you.